Okay, so today's topic, basically we have two topics. One is on final project plan and the final project. And the second topic is the continuation of chapter 7. And before those topics, I would like to mention several things. So first, midterm, I have finished grading midterm, just I didn't upload the scores. So generally, you did well in the midterm, so I don't have any concern about your progress towards the end of the semester. So if you submitted homework, I think you should be fine to do final projects. Of course, you have to spend much time to finish final project, but in terms of your skills and knowledge, I think it should be fine. And second comment, statistical coding. Yeah. Yeah. So statistical coding and usual coding is slightly different. And the biggest difference is in statistical coding, we have to use more, vectorized argument, and we have to use matrix and the vectors more. So suppose that we have some random numbers. For example, x is just 20 random numbers like this. And we want to pick up all positive elements. I don't know how many here. We have actually the fewer negative ones, 1, 2, 3, 4, 5, 6, 7, maybe 7. So we have the 13 positive ones. And we want to systematically count this. And, computer scientists, sorry. Yeah, so computer scientists often write a code like this. So we make a for loop, like the for I is equal to 1 to 20. And for each I, maybe we have to count the number. So we have to set the count as 0. And, if maybe if xi is larger than 0, then count is count plus 1 or something like that. And I think finally it returns count of x sub I. X is here. I is equal to if count. Oh, I think they just the typo. I have to put the space here, right? Then we get the count as 13. But okay, so this is the totally, the good code in computers for computer scientists, but the statisticians they make more vectorized argument because the language such as R, Python, MATLAB, those languages are specialized for vectors and matrices. So I prefer the code like this. So it's much simpler, right? So, in terms of, raw computer language, probably these two codes are almost equivalent and the speed is the same. But in statistical argument, we want to use the more statistical functions, and also we want to vectorize the argument. So X has 20 components, right? And we can calculate this condition for 20 observations at once. So it's much faster in, statistical languages. I don't know if you use C language, maybe the same, but yeah, that's it. Maybe, in terms of, maybe for some computer scientists, maybe, this, inequality isn't really beautiful because the left-hand side is a vector of 20 numbers and the right-hand side is just one number. So x is larger than 0 is a kind of strange argument. So maybe some people don't prefer it. And also the summation. So if you don't know the name of, if you don't know how this function works, then you may not like it, right? So the summation of x is larger than 0. True is 1, false is 0. And if you know all of those meaning, then this is clear. But for some computer scientists, maybe this code isn't very beautiful. But the statisticians generally prefer this kind of vectorized, the shorter arguments. Okay, so that's it. And yeah, anyway, so it's fine for most examples, but if the sample size gets larger, like the hundred thousands, the speed is different between these two codes. Yeah, some people criticize, data scientists because their code is not beautiful, and the other way around is also true. Okay, and that's it for comments and the final project. So I would like to share the screen from my iPad to show it. Sorry, I want, yeah, Zoom. Maybe I got some comments. So regarding pairwise t-test with Bonferroni correction, so do the variables being compared have to have the same length? No, you don't really have to have the same length. So for example, if you have 3 groups, the first one have 10 observations, second 7 observations, the third maybe 5 observations. That's fine. Yeah, so pairwise t-test, that pairwise means that you compare 2 groups at a time. So it's not the paired t-test, right? Paired t-test, we have, the one group of subjects and we have 2 variables. So in such a case, the number of observations should be the same, but the pairwise t-test that compares just 2 groups at a time. So totally fine that we have different number of observations in groups. Okay, so yep. So you are going to run final projects, and so far I have the 21 submissions of the midterm exam. So I expect around 21 people, maybe plus minus 1 or 2 people make a presentation. And I will ask most of you to present in real time during lecture. We have the 3 presentation dates. So December 5th and December 12th and December 24th. And the last day, yeah, I will ask you to attend for a little longer time. So last day, probably we will have a longer session for 2 hours. So we can, and one presentation is about 12 minutes. So we can put probably 5 in the first day and 5 in the second day and probably up to 8 on the third day. So I think that most of you can make presentation in real time. And I will ask some of you to make a video to make presentation. I don't know, maybe, like 2-1-1 or something like that. Then we can make all presentations and even videos. I will ask you to watch the video. Everyone watch the video. And I will ask you to comment on each presentation, just short comment, maybe 2 or 3 lines. And you will get the quiz credit for those comments. And I will forward your comments to the presenter and anonymous comments. So just give the frank opinion on each presentation. So that will help your classmates to, get some motivations for future presentations, maybe. Yeah, so those are, and we will decide presentation dates on Thursday. So just think about which day that you can make presentation. So of course we have to balance between the demand and the number of slots. But if sometimes you cannot really make a presentation because of some reason. For example, Wayne State University athletes have some events, and for example, if you cannot attend on December 7th, then you can exclude that. And if you cannot attend the Thursday's lecture, then I will ask you to send your request beforehand. Yep. By email. I got one question. Is just to do better valid comment? Is sorry, I said the just do better. I don't know. For the presentations. Oh, I see. So comments should be specific. Okay, so like excellent presentation or something like that, that isn't really allowed. So for example, if one person analyze, the population, for example, that you analyze population density by states, and you explain population density by average temperature of the states, for example, then you have to say that your visualization of the US map is good or something like that. So your comment should be specific. Yeah. So just do better isn't valid comment. Yeah, it's good question. Yep. Okay. Yeah, and the final project plan is due on this November 17th. That I will prepare the submission form later. But at first, I want to discuss the one presentation file, the past presentation first, because probably it gives the best, image of the presentation. And I uploaded the 3 sample presentations from 2 years ago. That is when I taught this class last time. And so you can see those. And so don't mimic the presentations. So your presentations should be original, but these are good examples of the presentations. I don't say it's perfect. So even if you mimic it, still you cannot make the perfect presentation. So this is the presentation given by the Tauhid Zaman 2 years ago. And he investigated the causes of preventable death by age in US. So basically the number of deaths by different causes is really different depending on age. So he analyzed that. And he makes some brief introduction to preventable deaths. That is like the drowning or the death by fire or something like that. That's fire, maybe not. Maybe suicide or something like that. And so he basically they used the data from 1999 and 2019 to compare the cause of the relationship between the number of deaths and cause of death by age. So it's important to give a brief introduction. So sometimes if you're fascinated by the topic, you make the introduction for 7 minutes, and in the last 5 minutes you discuss the analysis of data, but probably that's not good. So just a few minutes, maybe 1 or 2 minutes of introduction, and with the brief guideline. So most statistical presentation, at first you have to introduce what the data set is, then you make descriptive statistics, then you do some statistical inference, statistical analysis, then you make some this is another analysis. Then after that you summarize. And this is the data set he used. So basically for each year, so we have the 2 years in the data, so 2019 and 1999. So he wanted to investigate the situation has changed during these 20 years. And the number of deaths is recorded for each age. So 2019, we have age 0 to maybe age 100. And this database recorded the number of deaths for poisoning or motor vehicle and so on. It's interesting that age 0, the number of deaths by motor vehicle is smaller than age 1. Maybe at age 0, the babies are at home most of the time. Maybe it affects. Yeah, and different cause of death here. And he make a line graphs. This is what? This is the number of motor vehicle deaths by age. And you can see that the people get driver's license at maybe 17 or 18. So we have large number of deaths after that. But that number goes down by age. And actually it goes down and down. So I thought the curve is like this, but actually maybe old people don't drive the car, so that affects the number of deaths or something like that. But also you can see the difference between 1919 and 2019. And the one thing I have to mention is that these 100 data points are independent. So this is the number of deaths for age 1 and age 2, but these are different people. So we can regard those independent. But still we have some tendency. So much larger number of deaths around here, and much smaller around here. And some other deaths we have same thing. So poisoning and so on. And the falls, suddenly the most deaths are for the higher age. And some other factors. And he fits the polynomial to this death because we have some pattern. We have some complicated pattern, right? So to express this, we have some noise, but probably we have some underlying curve like this. So he wants to fit this curve. And this can be done by regression model. So far we have studied the only one predictor in regression model. So this is basically y, and we have coefficient and intercept, and we have age as x. But we can include some more variables. You can check chapter 11 and chapter 12. And in general, we can fit y on different variables like x1 and x2 and x3. And sometimes we can just make it first variable as age and second variable as age square. So it doesn't have to be age square. Maybe second variable is for example, the blood pressure or something that affects the number of deaths by fall. But here, he uses the polynomial regression. So he uses h square and h cube and so on as predictors. So in that way, that we can fit the curve. And so he uses up to degree n, but how to choose n? We have some method. It will be discussed in chapter 11, and he uses the most popular criterion, the so-called the Akaike information criterion, to choose this. And he did this for each of the cause of death. And also he did some tests whether age matters for the number of deaths for motor vehicle, for example. And also he checked if squared term is really necessary or something like that. And also that is this. So you can see this one, for example, the poisoning. Poisoning have, good curve. And I think that he fit probably, I don't know, this is the polynomial with degree 5. Yeah, degree 5. And that is much better than fitting just the straight line. This straight line doesn't really fit to the data. Data is these black circles, but this blue line at least fits better most of the part. Maybe this part is strange because the fitted line goes below 0, but generally it fits well. And this is the result. Yeah, always I recommend you not to use the raw R output, make a more beautiful table, but I think that he doesn't have much time to prepare for it. But you can see that the not only h, but also the h square or h cube. So these terms also affect with significant p-values. So certainly the degree 5 polynomial fits better. And this is for motor vehicle, almost the same, but he uses the different the number of terms. He uses up to cubic term, and he also reported the adjusted R square. So basically 77% of variation in motor vehicle death is explained by h square and h cube. And this, yeah, actually this curve fits well. He uses the polynomial with degree 13. We have very specific peak here, so that's why he needs a higher degree polynomial. And choking, droning, yeah, he did this for several ones. Yeah, and yeah, this one as well. And he also checked if there is a difference between the year 2019 and 1999. So 20 years that makes the society different. So he checked if so in addition to baseline coefficient, he checked if there is a difference. So if there is a change from 1999 to 2019. And he tested. Actually, this is covered in chapter 12, but he tested it. And also he tested whether his regression model fits well in terms of assumptions on residuals. So he make the QQ plot. So basically, his response variable is the number of deaths, but that is always non-negative number. So possibly we have to transform that variable by square root scale or log scale or something. And actually, original scale, if he used actually the QQ plot doesn't look good. So QQ plot does not follow the straight line. But if they take the logarithm of the number of deaths, it fits at least better than this one. We have some outliers because the log of small number becomes extremely small, but still it looks much better than this specific the curvature. So almost to follow the straight line. So he also used that. Yeah. And he did a test. So whether we have significant change in terms of the number of deaths over time. Then he concluded it. So that is the overview of the presentation. And his presentation is good. It has many graphs, so you can see what's happening there. Right? And also he uses many statistical methods. And also the number of slides. He have 20 slides for 12 minutes presentation. And of course, some duplications, in terms of the structure, because he discussed the same analysis for several different variables. So possibly your number of slides may be smaller, but probably like maybe 15 to 20, maybe I would say maybe 12 to 20 slides, good. Yeah, and do you have any questions so far? So this is just one example of the presentation. And you have probably noticed during this, sample slides that sorry, I would like to show this one. Yeah. So you have noticed that you have to know more statistical technique to develop a plan, right? And we haven't covered the later chapters. We have covered only chapter 1 to chapter 7, maybe the 7.1. And so I think it's beneficial to see what we will study in the remaining of the semester. So if you watch these 4 videos, these are from 2021, you can see the overview of the rest of the chapters. So you can check those videos to see what techniques are available. So maybe each video is about maybe 10 minutes, slightly less. So yeah, it doesn't take much time. Maybe I should upload the slides as well, but yeah, you can also see the textbook. And yeah, so the final presentation is in December. But before that, I would like you to submit a project plan. So due date is November 17th. And the project plan is just 1 to 2 page summary of your data and analysis plan. So you have to choose the topic and find the data and develop an analysis plan. So just I want to make sure that everyone is on the right track to make a presentation. So sometimes, some projects are not feasible, or sometimes, the data isn't, consistent with your objectives. So I would like to avoid that. So that is the 1 to 2 page summary. And I think the project plan, you will get some credits with the project plan. I think the 5% of the course credits. Until last year, I didn't give any points, but that gives you the impression that project plan is not important. So that's really the misleading. So that's why I give 5% of credits for this. Yeah, and I will, yeah, and the data set, you have to attach the data sample or just the data set itself as CSV or Microsoft Excel file. So sometimes students try to use the original data set, or students want to use the data set, but it's not organized yet. So in such a case, you don't really have to have the complete data at the time of project plan submission, but at least attach the all data sample so that which variables are available and how data look like. And the plan will not be graded, but will be returned with comments. And students may be asked to submit a plan again if the project is not well planned or not feasible. So you don't really have to worry about the score of your project plan, but just make a logical, reasonable plan. Yeah. Do you have any questions so far? Yeah, you can always also ask per question in chat. Oh, yeah, I got one question. How large should the sample size be for the data? Yeah, that's a good question. So yeah, I will discuss that somewhere around here. So yeah, I will discuss it. Yeah, and some tips to develop the sample project. Yeah, so just watch these videos that should be beneficial, or even read the textbook or slides. That may be even better, but it takes time. And set a meaningful objective in the real world. So that is a good advice. And yeah, so sample topics. Just to choose the good sample topics. I developed this document there in 2021. So every people are interested in the COVID statistics. Now, I don't know, less people are interested in that. But there may be other topics, economic statistics, maybe demographics, sports statistics, housing market data, and maybe presidential election and weather statistics, environmental statistics, the public health statistics. These are the most popular topics among past, the students in the past classes. And it is very welcome to use data from your research. If you are in the chemistry department or something, then you may have some research data, or you have part-time or full-time job that you have some data. Yeah, for example, I think that one student that worked for the Aritzia, that is, the fashion brand, and she has a part-time job there, and she uses the number of stores in each state and to analyze it. Yeah, actually, this is in a different class, but she uses the number of stores by state, and they explains what factors that determines the number of stores. Of course, the population matters, but the number of big cities or income level, the demographic, age distribution of each state, those things matter as well. And yeah, and avoid trivial analysis. That is also one important aspect. For example, you got some confidential medical data and explaining the left lung volume by the right lung volume. So of course, these two volumes are almost the same for most people. So this may not be very interesting. If you really get into details of medical context, maybe it's useful, but it's a kind of a trivial analysis. So hopefully you can get more interesting. You can set more interesting objective for the data. And the collecting data. And we have several different kinds of data. So one is original data from your research and the data from your original survey. So some students made an original survey and they use that data for final project. So I highly evaluate that kind of project. But also the data from the first sources is also good. So for example, download data from the Census Bureau website. So that Census Bureau, they compile that statistics. So that is good. But if uses, for example, data from newspaper, usually that is from another data source, maybe Census Bureau, Bureau of Labor Statistics, United Nations, and OECD, Federal Reserve, or something like that. So the use first source is good. And a kind of last resort is using the data repository, the UCI machine learning repository, or like the data competition website. So I will highly evaluate these, original data and the first source data. And the students use UCI and Kaggle, that's fine. Slightly, I gave the lower maximum score, but that's fine. Still, if your quality of analysis is good, you can get a good score. Yeah, and if you use the data competition data, for example, the Kaggle data, that is the largest data competition website, you should not set the same objective as data competition, because the data competition websites has ready-made code for analysis. So if you copy and paste it, then you can do analysis. So I don't allow it. But sometimes you really are interested in that specific data set. And if you set different objectives than data competition objective, then that should be fine. Okay. For example, some Kaggle data competition, they ask participants to predict the price of housing or something like that. But that data set itself is very good. Right? So in such a case, you can set different objectives. I don't know what's the good objectives, but yeah, for example, yeah. So for example, this may be not the best example, but for example, the size of the houses depends on the region or something like that. So these are the good examples. And one thing that some students have trouble is this. So don't plan to analyze summarized data. So some students try to analyze their, some students try to analyze already summarized data. So for example, a summarized table from 1,000 patients in a journal article cannot be analyzed. Okay, so suppose that we have some drug test and we have some control group and a treatment group. And the sample size, we have sample size of 500 control group, and we have 300 observations for treatment group. And the average age is about, okay, so 50 here, and then maybe 52.5 here, and average weight of is the 130 pounds here, and maybe 150 pounds here, or something like that. And if you only have summarized table, you cannot really analyze the data, right? So to analyze data, you need the all 500 values of ages and weights. So already summarized data cannot be used. Of course, if you have large set of summarized data, maybe you can use it. For example, if you have average height of 50 states or 100 countries, that can be used for your final project. But if just you have a summarized table, you cannot summarize it anymore. And this is recommendation, not exact requirement, but the another recommendation is use independent observations. Okay, so typical dependent observation is like the temperature data. Suppose that you have temperature data for daily temperature data from January 1st to December 31st in Detroit for 1 year. Okay, then you have 365 observations. Okay, so the number is good, but you know that have seasonality, right? So in January, the temperature is lower and December it's higher, and also some higher correlation between observations. If January 1st is very cold, you expect that January 2nd is cold, right? So observations have many, dependent structure, and also the distribution is not identical. So the January and July, the temperatures are different. So that kind of data are harder to analyze. So if you take time series class or something, then you can analyze it. But for this class, like linear regression, usually we assume data are independent. So my recommendation is pick a data set whose observations are independent. If not, still we have some ways. So you can consult me, but this is my recommendation. And don't choose too large or too small data set in terms of the number of variables and the sample size. And the number of observations, I would say that maybe at minimum like 30 observations, and the maximum maybe, it really depends, but the up to maybe 100,000. If you have millions of data handling itself is more difficult. And the number of variables, predictors or something, at least you need maybe 3 or 4 variables to make some variation in your analysis. It really depends, but at least maybe 3 or 4. And the number of variables, maybe up to 100 may be fine, but if larger than that, I think it's probably really hard to deal with. Of course, original dataset is large and you only pick up 5 variables. That's fine, but if you have too many variables, probably it's really hard to analyze it. Yeah, so certainly I don't really recommend to use like the video data or image data. That's hard to analyze. Yeah. Even if the image is 100 by 100 pixels, and you have, suppose, 10,000 images, maybe 3,000 images. 30,000 images. Then 100 by 100 pixel image. The one image have basically 10,000 variables, right? So that means the number of data points is 30,000 times 10,000. That is too large. Even if the number of images is small, 500 or something, still, I think it's too hard to deal with. Yeah, so probably that answers the question about how large data should be. And I got another question. So if we want to use data from an original survey, we should have this survey completed by the time of the project plan due. No, you should have the plan, and you should have the how final data set look like, but you can gather data after project plan due. Yes, but realistically, probably you have to finish the survey by maybe November, at latest, maybe November 25th or something like that. Yeah. Okay, so I got another question. What about the remaining 16%, 24% for the maximum scores? Yes, oh, that's great. So basically I set the 80% as the maximum, okay, and the as the score. So that is because I would like to give some bonus credits for excellent, outstanding presentations. So up to 35% of students. So I think original enrollments of this class is 30. So the 35% means maybe 10 or 11. Up to 10 or 11 students get the higher score. So bonus credits of up to 20 points. And bonus credits is based on several factors. The one is the vote from another student. So I ask you to vote for the best three presentations, and based on that, I will give some bonus credits. And also I will evaluate your project in terms of objectives, data quality, and the quality of analysis and the presentation. So based on those factors, I will give actually more than half of the awards. So that makes another 20 points. So I would say that if you are serious about the project, you are most likely to get around 80 points, 76 or 48, for 84. And some excellent presentations that gets the bonus credits up to 20 points. Does machine learning work for the final project? Machine learning models are more, advanced model than final projects, and you can use it. It does not necessarily get more points, but you can use it and compare it with the models in the course. But if you use the model which is not covered in class, you have to briefly explain what the model is. And if you really need more time to explain it, you can just consult me earlier than before presentation. Then maybe I can give a couple of extra minutes. So I don't really recommend it, but you can use it if you are interested in. Okay, and that is the point. And the next point, so consider statistical methods appropriate for your research question and data. So we have studied, for example, regression and ANOVA. ANOVA is for the categorical data, categorical predictors, and regression is continuous predictors. And we have some classification data. Classification data is like the female and male, and the people who like the pink car and people who like the white car or something like that. Then we have some tendency like maybe 40, 20, 50, 20 or something like that, right? So we can deal with this kind of categorical data in chapter 8. So the different data have different way of analysis. So just use the appropriate methods for analysis. And in project plan, just the exactly describe what you are doing. So what is your response and what is your predictors and so on. Yeah, so one big mistake is the mimic the sample project plan. I will discuss it soon, but just think about your data set and make a logical plan. And finally, the evaluation criteria for final projects. So basically, you get about 80 points if your presentation is good. If not good, the lower scores, but the majority of students get around 80 points. And crucial errors, inadequate analysis, poor presentation may lower your score, and outstanding presentations, at most 35% of the class will get 10 to 20 additional points. And the point of evaluations are data quality, quality of research questions, appropriateness and creativity of data analysis, and votes by classmates and the presentation. Yep. Do you have any questions so far? Okay, and now I want to discuss the sample project plan. So how sample project plan look like? Maybe just I briefly discuss it. So sample project plan is just the 1 or 2 pages. So this is the first page and this is second page. Actually 1 page, 1.2 page, I would say. And this is the the sample data format. For this particular question. So sample project plan, you put some title here, put name and objectives, and describe data briefly. So in this case, I investigate the salary and the performance of baseball players. So basically, we want to get the relationship between these two. So all fielders have salary data for 2015 and 16. And also we have regular season statistics for 2015. And we have also the demographic information for 3 baseball teams, ABC. And you specify the data source. This is from USA Today website. And you can specify what website it is. And salary is the continuous variable. So players statistic includes the 16 continuous variables such as age or height or something like that, and some categorical variables such as the dominant hand and position and so on. Then you can get the sample sizes and so on. So just describe data as concrete as possible. Then you have analysis plan. So at first, you make some box plots, scatter plots, correlation matrix, and so on. Correlation, yeah, yes. And you can specify what kind of model are you planning to use. And maybe possibly we have different response variables. Maybe sometimes you want to explain just the salary, level of the salary, or increase in salary, or something like that. And how to choose model and how you would analyze data. Yeah, and this is another plan to see if baseball player's salary depends on the team used by using the ANOVA. So this kind of thing I would like you to have. Yeah. So that's the sample project plan, and we have these files in Canvas, so you can see it later. And what does AIC mean again? So AIC is the statistic to explain which model is better for prediction. I will cover it in chapter 11. So when we compare models, for example, one model is very simple model with one predictor, and another model have 100 predictors, and it explains why better. But if you use many predictors, of course, the model performance gets better, but it does not guarantee for the new data points, you can predict it better. So AIC, they characterize the model so that so AIC can compare which model is better for future prediction. So that is the AIC. And data sources, you have different data sources, and these are possible data sources. Of course, there are many other data sources. So so it is, at first ideal that if you can find the first source data, such as from government organizations or your workplace or your own research. Alternatively, you can use the data repository or a competition website. And competition website data, you have to set your own objective, different from competition objective. And and these are some examples of the data source. For example, some weather data, National Center for Environmental Information. And data.gov. This is actually a kind of data repository, but I will give full credits if you use this data. So basically, different organizations upload the data to this website. For public health data, the CDC. Educational data, the National Center for Educational Statistics. More local data, the data.michigan.gov. And nationwide economic data, the BLS, Bureau of Labor Statistics, Census Bureau. International data, OECD. OECD is basically an organization to collect data in the same format, in the same in the same rule, the same method from different countries. International Monetary Fund, the Eurostat, the United Nations, especially if you want to compare countries, Federal Reserve Board, European Central Bank, and some real estate data. Maybe real estate data, these days you can use the Redfin or Zillow to download data. Maybe some municipal websites have real estate data as well. And some search engine portal website, the Yahoo Finance, Google Trend data. So these are time series data, so it's slightly harder to deal with, but so just I put it in parentheses. So various sports data are readily available in baseball website or basketball website and so on. And some articles discusses the a list of data sources, so you can check it if you would like. And data repository, or something. So these are just examples, so you can use any data source. Okay, so that's it. And do you have any other questions? I think so these are just the explanation for final project plan due November 17th. Maybe you can just consider what data are you interested in. Then project plan, maybe you can make it maybe 2 weeks later. Then more materials in class. So that may be a good idea. Okay. And that's it. And generally for data science, oh, sorry, I got many questions here. Maybe do you have example of? Oh, but presentation. Oh, sorry, we have several. Do you have any words of encouragement? Sorry, what do you mean? Okay, next question. Will sports data website get full credits in terms of type of data used? Yes, so full credits, 84 points. And do you have an example of the BAT presentation? Yes, one student get very low score because he recorded video in the car. He didn't show any slides. I think he showed slides, but he just record his PC screen by phone or something. He showed maybe a couple of slides, but almost the invisible, I would say. So it's very hard to read slides. And the topics are not really statistics. So he uses some mathematical, he discussed some mathematical problem, but it's not entirely statistical. And the presentation is like 5 minutes. So I gave very low score for him. And finally he passed, but I think he have a very low grade. And another about presentation. So just the one lady make a presentation, but he only have introduction, and he doesn't have any. She doesn't have any, summary of the data and no analysis. So those are probably the bad presentation. And also, you have to make presentation as scheduled date. So that is very important. So this replaces final exam. So if you don't make presentation, it's the same as no show in final exam. So you will not get credits. Okay. Do you have anything to say that motivates us to do good? Yeah, okay, motivation, I see. That's a hard question, right? Yeah, actually, some students get part-time job if they are good in applied statistics courses. So that's one good thing. Yeah. Yeah, so I would say that this course is really the time-consuming class and the demanding class, but this is very applicable and practical course. And I would say that if you finish this course successfully, it's probably like 10 times or 20 times as useful as some more theoretical courses probably in your life. So that is really useful. Like the people who becomes like the actuary or data scientists or even some other jobs, they said really this course is useful. So it's time consuming, but if you finish, then it's really good. So you are saying that if we do bad, we are doomed to live a poor life. People have different, specialities. So, doing bad in this course doesn't mean you are doing bad in English literature, right? So you are totally fine to find another place to work, but yeah, that's it. Okay, so I think I spent a lot of time, but yeah, I think I discussed important things, so that should be fine. Okay, so we continue chapter 7. Yeah. Oh, before that, maybe I have to take attendance, so participants. So maybe I have to end sharing at first. Oh, sorry. Oh, no, no, no. Hmm. Um, hmm. Okay. Okay, I screenshot the attendees. And I will continue chapter 7. Yeah, so last time that I did one-way analysis of variance. This is the generalized version of t-test. So we have more than 2 groups. The 2 groups is also fine, but it can accommodate the situation that we have more than 2 groups. But we have the assumptions in the model. So you can just go back to slide sorry. Yeah, here. So assumption of ANOVA is here. So observation Xij is explained by group and error. And error is normal and IID. But this normal assumption is not satisfied sometimes. So in such a case, how to do? Yeah, one way is transform the data so that the data becomes normal. That is one good way. But sometimes it's really impossible to make it normal, and we don't want to rely on normal assumptions. So how to do in such a case? That is today's first topic. And that is called the Kruskal-Wallis test. Okay. So this is a kind of the version of the Wilcoxon rank sum test for general case. So suppose that we have observations. Maybe this is not really a good example because we cannot really check normalities with this small data. But suppose that the normality assumption is not likely to be satisfied, and we have 7 observations. Then how to test? And the idea of Kruskal-Wallis test is we only use the rank of observations. So out of these 7 observations, the 6.6 is smallest observation. So we replace this 6.6 by 1. And the second smallest observation is 7.6. So this is 2, and so on. So we only use these ranks to test the, between the difference between groups. So that is the idea. So if you calculate the ranks of these 7 observations, the overall, these are 1 to 7. And group 1, the observations have rank 4, 6, 7. Group 2, 2, 5. Group 3, 1, 3. So it looks like group 3 has higher rank. So the numbers are smaller than group 1. Even if we ignore these numeric values, still it's valid. So using this idea that we calculate some quantity, and the quantity is calculated by this. Sorry, maybe I should use these observations first. So we use the group mean. So these group means, and overall mean. Overall mean should be 4 because we have 7 observations. And overall mean in this place, and the group mean is these 3. So these 3 are here and here and here. Then we put the number of observations. So we have 3 observations, 2 observations, 2 observations for each groups. And so this number basically explains sum of squared deviation between groups, right? So difference between, a kind of the variation between groups. So compared to the entire average, how different each group mean is. So if we take the deviation and take square and take summation, so if this number is large, then that means the difference in groups difference by groups is large. So if this number is large, then it's an evidence that groups have different mean. Then, so based on this number that we test, so that is the scheme of the method of this Kruskal-Wallis test. So this is, the more generalized version of the Wilcoxon signed rank test, a Wilcoxon rank sum test. Wilcoxon rank sum, but more than for more than 2 groups. And this statistic that are shown in the next slide actually is known that so this statistic follows the chi-square distribution with the number of degrees of freedom equal to the number of groups minus 1. So if 3 groups, chi-square distribution with df2. So this is the Kruskal-Wallis test. So our assumptions are these errors are IID, but not necessarily have normal distribution. So that's the Kruskal-Wallis test, and this is one example. So Kruskal-Wallis test, paired t-test, and so on, ANOVA. The format is always like this. So these are observations. And the second vector variable explains group for each observation. So first 3 observations are in group 1, second 2 observations, the next 2 observations are in group 2, and so on. Then you can do just Kruskal-Wallis test X, the tilde group. Then you can do it. I think probably it's more safer to make this as factor vector, like the as factor group. It's not necessary, but probably this is a good, custom to avoid errors. And this returns Kruskal-Wallis test result and the chi-square statistic of 3.6071. And we have 3 groups. So G is equal to 3, and the G minus 1 is equal to 2. So we have DF equal to 2. And chi-square distribution with degrees of freedom K, expectation is K. So typically this value is 2, but this is 3.6, so relatively larger. So if we have distribution of chi-square 2 like this, and 3.6 is probably around here. And p-value is 0.16. So it's more than 0.05, so H0 is not rejected. So that means we cannot really say these 3 groups have different means. Yeah, you can code it from scratch. You can count and so on. You can count rank, calculate the mean for each group, and so on. And you can get the result. Yeah. So often in the application, some articles do ANOVA, but sometimes ANOVA assumptions are not satisfied. So as an alternative, they run Kruskal-Wallis test. I have seen it in many medical journals I wrote with medical doctors. Yeah, and that's it. And probably it's, yeah, yeah. And at first, I would like to discuss this slide. So the Kruskal-Wallis test does not use any, normality assumption, and it entirely depends on the ranks of observations. So we don't really have any parametric assumptions. So the ANOVA model assumes that xij is equal to like the mu I plus epsilon ij. So that means, okay, so I is equal to 1 to I, and j 1 to I, and j is equal to 1 to n sub I or something. And this basically describes the situation by finite number of constants, right? So suppose we have 3 groups. Basically, our assumption is that the mu1, mu2, mu3, these 3 numbers explains the data structure. So we have only finite number of parameters explain the situation. So that is called the parametric assumptions. Estimation and the testing methods without use, yeah, so these are parametric assumptions. But if the estimation or testing do not use this kind of parametric assumptions, these are called the non-parametric methods. For instance, the Kruskal-Wallis test, or Wilcoxon rank sum test, or Wilcoxon sign rank test. So these are non-parametric tests. So simple linear regression uses AB and sigma square. So this is parametric. And a t-test uses the mu and sigma square. Maybe 2 sample t-tests use mu1, mu2, sigma square, sigma 1 square, sigma 2 square. But this is just a finite and fixed number of parameters. So these are called parametric methods. I think I got one question. So H naught is always that the mean are the same. Yes, realistically, that's true. So t-test, maybe we can set different alternative hypotheses, but the Kruskal-Wallis test, probably H naught is always the all means are the same. Yeah. Otherwise, it's too complicated, and probably we cannot really do other things. Yeah. So Kruskal-Wallis test, the H naught is always the all means are the same. Okay, so yeah, actually, I made a survey about how you would like, the how we do exercises. And actually, the majority of students prefer to discuss examples by me rather than having the breakout rooms. Basically, about the 70% of students prefer more examples in lecture rather than the, time for exercises. And about the maybe 25% that prefers the current style. Maybe about maybe 25 to 30. So I will reduce the number of the time for exercises, and I will discuss some examples. So I don't really have much time today, so 2 minutes. So I just want to discuss the exercise 3 here. So in exercise 3, we have 3 groups, and we want to do Kruskal-Wallis test. So sorry, maybe I don't have enough time here, but yeah. Okay, here. So group 1, group 2, group 3. So we have this, and makes box plots side by side for 3 groups, and they do a Kruskal-Wallis test, and also do analysis of variance, and we want to compare the result. Okay, so we want to copy and paste this into R. I hope it works. Probably it works. Yeah, G1, G2, G3. And to do ANOVA or a Kruskal-Wallis test, it's useful to make it just a one vector. So I would say the vector X, maybe we combine this as G1, G2, and G3. So X is this vector. And we want to have the group names. So I define G as group 1 for 1, 2, 3, 4, 5, 6, 7. So 7 observations. So maybe we repeat G1 7 times. Okay. And the group 2, we have 6 observations. So maybe G2, 6. Maybe more polished code looks like this. So length G2. And also, I would say that this is length G1. Okay. And the repeat G3 by 6 observations again. So length G3, okay. Length G3. And that we use this as one vector. So this, then G is this vector. Okay, so maybe just in case we make it as factor, then G. Then we can make box plot by G. So X by G, then we can make this box plot. So you can see we have one outlier. So in group G1. So G1, the median is much lower, but this one outlier makes the maybe probably the mean higher. And G2, G3, G2 is probably larger than G3 in terms of X value. And we can do Kruskal-Wallis test by using the Kruskal.test function. So what's that? This is the Kruskal.test function, and the first element is X, and the second element is actually that we do this. Then, yeah, it actually rejects null hypothesis. How about ANOVA? ANOVA is X tilde G. Then it gives, actually it does not give any significant results. So this is because the one outlier. So if we ignore outlier, we can see the difference between G1, G2, G3. But if we include this outlier, probably the mean of G1 is around here. So basically the mean matters for analysis of variance. The median matters for classical Wallis test because we use ranks. So that makes the value different. And certainly this outlier distorted the result. So in this case, classical Wallis test is more appropriate. Sorry, I extended for 2 minutes, but I got last question. What is the purpose of using as dot factor for discrete numbers? Yeah, so we have several classes of vectors. So character vector and factor vector. And the character vector, even if the R read this, R does not recognize the first element and the second elements are the same. Just the R record this as strings. So if we make it as factor vector, the R automatically recognizes these 7 observations are the same observations. So that's why it's more natural to make this G as a factor vector. I don't know, maybe without this line, it works fine, but just in case, I make it a factor vector. Okay, thank you. And if you don't have any questions, this is the end of the class, and I will upload your midterm score tonight. Yeah. Okay, see you later next time.
Thank you.